Hello and welcome to Sean White's Solar and Energy Storage Podcast. This time we are talking energy storage, and we're going way back to the way that this podcast first started. I was just playing some of the greatest hits of some of my classes. So I have a lot of online, on-demand classes, and this way you can see how fun the classes are, taking these really fun subjects like codes and standards and things, and just enjoying ourselves so much talking about these things and learning and getting to know. So this particular podcast is going to cover a lesson from my 40-hour NABCEP Advanced Energy Storage Certification training. So this training is typically used by people trying to get their ESIP. That's the NABCEP, that's the North American Board of Certified Energy Practitioners Energy Storage Installation Professional Certification. So at the time of the recording of this podcast, which is in 2025, that's January 2025, we have 11 people on the NABCEP website that have taken the ESIP exam. If you ever want to find out who has the certification, who's a NABCEP certified installer close to you, lots of great reasons to go out and find these people. You just go to the NABCEP website, and then up at the top of the page, you click on Professional Directory, and then you can do a search for all the different certifications by location or just everybody in the world, like what I just did right here. And I found 11 people. And I know that most, if not all of these people, took my HeatSpring 40-hour course. And when you sign up for the 40-hour course, you will hear this video a second time because you're going to hear it right now. If you want to see the visuals, you can go check out the podcast on YouTube. Yep, it's more exciting than Mr. Beast. Enjoy. Now what we're doing is we are looking at development, which is 15% of the JTA, and we're talking about identifying and managing customers' expectations. Yep, that's an important thing. We got to make those customers happy. And although you are taking a class and getting yourself educated, this is about you educating yourself, educating other people. That's a lot of times what you're doing with your knowledge is educating your customers and other people that you're working with. So a lot of these things too are things that you already know, but it's good to learn how to explain them to other people. So when you're talking about an energy storage system, I'm sure we've mentioned this before, but we have power and energy. A lot of times with a PV system, you're just talking about power. How many kilowatts is that PV system? Now what we're doing with an energy storage system is we're talking about power and energy. And it's sometimes difficult to get that across to your average homeowner. So a homeowner might not know the difference of these things. And they're just like, well, isn't it this many kilowatts? Shouldn't it work? Things like that. And we're going to be looking at power is the inverter rating, usually of an energy storage system. And then power times time equals energy. That's a lot of times the batteries that you're going to have in an energy storage system. That's how much energy you have. So the inverter, we can talk about that as being rated in watts, kilowatts, megawatts. And the batteries, we talk about amp hours times volts or watt hours. We have watt hours, kilowatt hours, and megawatt hours. Now we're going to talk about these currents. And there's all different types of ways to talk about currents. So that's currents, that's the flow of electrons. That's an amp. An amp is about 6.2 quintillion electrons per second. That's right, electrons are small. So when we're looking at our inverters of our energy storage systems, there's going to be these rated currents. And those are the continuous currents. And that's a lot of times how we talk about the inverter. So is that inverter going to be 5 kilowatts, 50 kilowatts? And then there's going to be these extra rushes. And so we're talking about the AC side of the inverter. So if the voltage is constant, then power and current are going to be relative to each other because voltage times current equals power. So besides the rated currents, the continuous currents, we have these inrush currents. And those are the currents that are going to get things to get going. We've talked about that a bit. So they call it a surge current when you're talking about an inverter. And here's an example. We have an Outback off-grid inverter. And so this inverter, they're giving it to us in apparent power volt amps. For this purpose, we're going to figure that everything's in phase. So your VA is the same as your watts. And so we've got a 2000 watt inverter. And for 30 minutes, it can give you 2,500 watts. And for 5 seconds, it can give you 4,300 watts. And for 1/10 of a second, that's 100 milliseconds, it can kick 4,600 watts at you. So that's just going to show you that this 2,000 watt inverter that we would describe as a 2,000 watt inverter can give you up to 4,600 watts, and that's for these different levels of surges. And so those would be those inrush currents, otherwise known as locked rotor currents, these different currents to get things going, those non-continuous currents. Then what we have are short circuit currents. From an off-grid inverter, like the one that we were just looking at, a short circuit current on the AC side over there, all it's going to do is it's going to go over those currents that we were just looking at. So you short circuit it, it's just going to turn off. Any kind of electronics are going to turn off. So that would be coming out of a DC to DC converter, coming out of an inverter. If you're a standalone inverter, it'll just turn off. If you're connected to the grid, then the big currents will come from the grid and set off overcurrent protection. If you short circuit something on a battery side, where you're just looking at the battery terminals without electronics, then you could have a disaster waiting. So then you can get those super huge amounts of short circuit currents. The dangerous super huge amounts of short circuit currents aren't going to be coming from inverters, they're current limited. It's not going to be coming from PV, that's current limited. It's going to be coming from naked battery terminals that are just going right down into the battery. And they're also going to be coming from the utility when you are on the supply side of all overcurrent protection devices. The next thing about currents that we're looking at here is the KAIC. That's thousands of amps interrupting capacity. And that would be a rating that you would have for, say, a circuit breaker. So you might have a circuit breaker that could handle up to 10,000 amps. It might be a 20 amp circuit breaker, but if over 10,000 amps came rushing at it, it wouldn't be able to handle that much. So maybe you would have that on the load side of a main breaker that could handle more ampere interrupting capacity. So the KAIC. So here's a data sheet of a circuit breaker, and we can see that that's a 20 amp breaker. However, there is the interrupt rating, so also known as thousands of ampere interrupt capacity, or interrupt rating would be the same thing, KAIC. And so this would be 10,000, 10 KAIC is what we could call it. So if more current was rushing at it than 10,000 amps, then this thing might not work and interrupt the circuit. It could catch fire. So that's one reason why you're not going to take a little wimpy circuit breaker and stick it on the supply side. That's why you might have a main breaker that could interrupt a lot more amps. And then another thing too is we have currents that are AC and DC. We need to make sure that we have equipment that is rated for DC, especially if we're going to interrupt DC currents. So there's the currents, just like a river. And now we are going to talk about powers, different ways of looking at power. And typically we're just talking about real power. That would be measured in watts, kilowatts, and megawatts. That's the real power. But one of the things that happens sometimes is you get voltage and current, and they're peaking at different times with alternating current. And when they're not peaking at different times, when they're peaking simultaneously, then your VA, that's your apparent power, is exactly the same as your watts, your real power. And you would have no reactive power. Reactive power only happens when things are out of phase with each other. And on the grid, you're always out of phase. So there's your apparent power, your real power, your reactive power. It's good to know about these things, but you're probably not going to see too much of this on the test, but you should know how to identify what these things mean. Reactive power can be very important on the grid. It will help support voltage. So if you're transmitting electricity over long distances, it helps keep the voltage from sagging and things like that. And apparent power is used to size the wires and the equipment So your apparent power can end up meaning that your currents are greater than just your real power divided by your voltage, getting currents that way. And of course, you don't get any of these things being out of phase with direct current because it's direct current. It's not going up and down 50 or 60 times per second. And so we're just trying to manage our customers' expectations, and our customers probably don't need to be educated on things like reactive power. But as time goes on, we get different grid codes that require some of this in some instances. Now we're going to talk about these different battery capacities, and this is important for your customers to understand. So we've got our usable battery capacity, our state of charge, our depth of discharge, and one of the things that we need to explain to our customers is just because a battery can be charged all the way up to 100% and discharged down to 0%, it's almost never a good idea to do that. There are some exceptions, like you can do that with a flow battery. You can do that with nickel iron batteries, which are not very common, but you can do that with those things without causing any damage. You can do it with a capacitor, but you're not going to be doing that with lead acid batteries or lithium ion batteries. So lead acid batteries are most healthy when they are 100% charged. So a lot of people living off grid with lead acid batteries, they go up to 100% and they might go down to 50%. I know some people that have 20-plus-year-old lead acid batteries, and they try to always keep it above 90% state of charge. So once it gets down to 90, they just turn on the generator, and they have batteries that they know very well that have been just sitting around forever. They know those batteries so well, they probably have pet names for every different cell. They have a certain cell that needs a little bit extra water. It probably gets a little bit hotter, speeds up chemical reactions, and it makes some of the battery acid in that cell turn into hydrogen and oxygen with electrolysis. That's what happens when the battery cell is hotter. It's easier to speed up those chemical reactions. So lead acid batteries, it's healthy to go up to 100%. If you don't go up to 100% every day or two, depending on who you talk to, it's bad for the batteries. It causes lead sulfate crystals on the battery cells. One of the ways to get rid of those lead sulfate crystals is to do an equalization charge. That's a controlled overcharge. That's the highest charge that you will see on a lead acid battery. And people only do equalization charges with flooded lead acid batteries that you can add distilled water to, because with a sealed battery, if you get some gassing from an equalization charge, that means you're getting rid of some water molecules in there, splitting them up, turning them into hydrogen and oxygen. And then what are you going to do to replace those water molecules? There are some exceptions. Remember, I was doing a class in Islamabad, and they were doing equalization charging on lead acid batteries that were sealed. And I imagine that those batteries aren't going to last for a super long time. So the main type of battery chemistry that we're using these days for stationary energy storage systems, the BESS, is the LFP. That's the lithium iron phosphate. And with lithium iron phosphate, it is okay to go up to 100% state of charge, but follow the manufacturer's instructions. And it's not bad to keep it at 80% charged for months. It's not like it would be bad for a lead acid battery to do that. In fact, if you were going to keep it at 80% charge for months, it's probably, in my opinion, and according to most manufacturers, healthier for the battery to be at 80% charge for months than 100% charge for months. But it's not a bad thing. It's not a sin to charge a lithium iron phosphate battery up to 100%. I know that we have some lithium iron phosphate batteries, and they say to fully charge it once a week. Different manufacturers will give you different ideas. And also, what do they mean by 100% state of charge? That's going to be a certain voltage that they determine with their software.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
And then we have the trinary batteries. That means it has three different things besides the lithium and oxygen. So we have lithium, nickel, manganese, cobalt oxide, and we have lithium, nickel, cobalt, aluminum oxide. And typically you're looking at the NMC, but some of the older batteries and stationary energy storage systems are the NCA. And it's okay to go to 100% sometimes, but it's not good for the battery. It's sort of like eating at McDonald's. Don't do it every day. It's not good for you, but once in a while, probably not going to kill you. I know when you're selling a car that has one of these types of batteries, the NMC or the NCA, you want to charge it up to 100% so the person that you're selling it to can see what kind of range that car has. And they say that if you're going to go on a super long trip, go ahead, charge it up to 100%. But you know what? I still don't do it. I just want my battery to last forever. It's 9 years old. It's working pretty good, knock on wood. And so here's what we have. We've got the depth of discharge and the state of charge. And one of the things that I've heard about the NABCEP test is a lot of times the questions are phrased like for a lead acid battery. So they talk about an 80% depth of discharge, and you just have to kind of assume from the wording of the question that they mean that that battery is going up to 100% state of charge. And so that would mean you're using 80% of the battery in that case. But I like to talk about the usable battery capacity, because a lot of times what's happening, which we don't see in this picture, is you're going from 80% to 20%. And so that means you're using 60%. 80 minus 20 is 60. So you would be using a 60% usable capacity. That's what I like to do with my lithium-ion batteries, but I don't have the ability to even control that with my watch, with my phone, with my computer. And I think I should be able to control that with those things. But especially the people selling you the phones, they want to sell you a new one as often as possible. So if it lasts for a year, that's just the way they planned it. What do they think, that we're stupid and we don't know how to do battery management for our phones? I think we should have more control. I think that should be a law. Consumer activist rights laws. Okay, so here's one that we typically aren't going to be doing, but in an emergency, we would do this with any battery, going from 100% state of charge to 0% state of charge. That's the same as going from 0% depth of discharge to 100% depth of discharge. So we're going from the left all the way to the right. This image, by the way, came from a company called Simplify. They make some lithium iron phosphate batteries. They're now called Briggs & Stratton. So as I was just saying, for the lead acid battery, the depth of discharge is the same as the usable battery capacity. So if we're going to go down to a 50% depth of discharge, which would probably be 12 volts for a 12-volt battery, fully charged 12-volt battery without a load, without a source charging it, is about 12.6 volts. So 12.6 volts down to 12 volts, that would be about a 50% usage of the battery. So you're charging it down by about 50%. And lithium-ion batteries, oftentimes not charging to 100%, sometimes read the instructions, and how do you define 100%? It's going to be some voltage, and they could change that definition with changing the algorithms, with the programming. It's crazy. So here it is, 80 to 20%. We just go 80 minus 20, that's 60% usable capacity. We're going to do some math with that a little bit, but the derating factor is 0.6. You want to find out how many batteries you're going to use. If you only want to use that much of your battery, then you would divide by 0.6 and increase the size of your battery bank. So the manufacturers, they control these things. They're part of the deep charge state, the deep state, figuring out what your state of charge and your depth of discharge is going to be. And they may change those parameters years after installation. If they were devious, what they would do as soon as your warranty expires, they would change those parameters to kill your battery as soon as possible. And that's another reason why I look at my batteries and I try to keep them in a certain window that's conservative, so it'll just extend my battery life even more. So look out for those companies downloading their algorithms. They probably have it in the fine print that they can do that. Now we're going to consider what we call days of autonomy. So what does autonomous mean? You have autonomous vehicles driving around these days, picking up people like an Uber with a ghost driver, And that means alone, autonomous, all alone. So how many days your batteries can go without charging would be your days of autonomy, not dead on arrival. DOA is days of autonomy. And typically, you're going to see people going 2 days, 3 days, but if somebody's a super prepper, they might go 30 days of autonomy. That would be lots of batteries. That's not just a super prepper, that's a super prepper with a super wallet, billionaire, or maybe 10 million. There's probably somebody taking this class that's got 10 million. So then, if you don't want to have all these days of autonomy, what you do to compensate is you have another power source. So you can have a generator. That's really common. Like most off-grid systems do have generators. If you're even backup for a hospital, you're going to probably have a generator, something like that. And another neat backup, the backup of the future, is you have your electric vehicle. You just drive it down to the charger of some place that isn't having an event, or your neighbor's house that has too much solar, and you go take some of that energy and bring it on home. Go to the store, you pick up some eggs, some milk, some kilowatt hours. Or the other thing, which is kind of neat, it's called camping or living in the 1800s. And you just do it without electricity. You do candles, you sleep, you hang out in the dark. And by the way, did you know that there's a relationship between a power outage and 9 months later, a baby boom? I wonder why that is. I'm not going to tell you about the birds and the bees. I'll let you figure that out yourself. So let's talk about energy optimism. So derating factors. Sometimes if you're taking a test or in real life is a test in a way, maybe. Depends on your philosophy. And if you lose 20% and you're like, I lost 20%, you're a pessimist. So flip it around and remember how much you keep, 80%. So if you're talking about losses, you take 100% minus your percent losses, and that's how you figure out how much you keep. You're a glass half full kind of person. Then you figure out that percentage that you keep, and let's say it was 80%. You move the decimal 2 places, turn the percent into a decimal, you got 0.8. You probably already know how to do that if you made it this far. And then a lot of times what happens is we have the energy that we need, and we need to increase the size of the battery bank because of efficiency losses or how much you keep. So if we needed 4 kilowatt hours and we were going to lose 10%, or we could say we're going to keep 90%, then we take 4 kilowatt hours divided by 0.9, and we get that number that's 4.44 kilowatt hours. That's the math. Get really used to that kind of stuff. Know how to take a number. You're pretty much, when you're designing a battery bank, you want your numbers to get bigger. You know, there's going to be all these different reasons, days of autonomy and efficiency and all that kind of stuff. And so what you would do to make your number bigger is multiply by numbers greater than 1. That's obvious. Or divide by numbers less than 1. That's it. That's all there is to it. Have a positive attitude, glass half full. It makes it easier to learn too when you're happy. So just remember some of these different factors for design. We've got the energy requirements. Those are important. Know what's your energy that's going to be required. Your power requirements, what's the power that's required. And if you're going to be islanding, if you're going to be standalone, if you're going to be off-grid, if you have battery backup, you got to remember you need that peak power to get the motor kicking. And we've looked at that a few different times already. Other important factors would be your derating factors, which you can calculate from your efficiency or your losses, and your temperature. Hopefully, you have an energy storage system with a battery that has conditioning for your temperature. So you have heating and cooling. Or sometimes what you just have is a way to monitor the temperature, and if it gets too hot, it just turns it off or slows things down to keep it in the range. Because getting too hot for a battery reduces the life of the battery, especially if it gets too hot and it's fully charged and it's a lithium-ion battery. That's not a good thing to do on a regular basis. Okay, so now we are going to do a little bit of review here for identifying and managing our customers' expectations. So what you can do now is explain or think about state of charge, depth of discharge, and usable capacity. Push pause if you like, and don't push pause if you don't like. Let's look at the next thing here. State of charge, that's the SOC. So when the battery is fully charged, your state of charge is 100%. And your depth of discharge, when your battery is fully dead, then your depth of discharge is 100%, and your state of charge would be 0%. When your state of charge is 100%, your depth of discharge is 0%. So state of charge plus depth of discharge should equal 100%. Batteries are rarely taken from 100% state of discharge to 100% depth of discharge for battery longevity. Only if there's an emergency would we do something like that, or an accident, like when you left those headlights on. That's not good for your battery. It kills the battery if you do that too many times. And I like going by usable capacity because we've left the lead acid era, if you didn't notice that. But people writing these tests, a lot of times they're still stuck in the lead acid area because if they had to do it, you have to do it. They're old timers and they love the sweet taste of lead. That's how Romans sweetened their wine. Now we're going to talk a little bit about load calculations for energy. So load calculations, how do you calculate that? Dun, 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 dun. Power times time equals energy. And another thing too is you can have a little shortcut. Don't forget. Sometimes people forget about 24 hours per day or 30 days per month or 365 days per year. Especially on a test, they forget some of those things. Another thing that a lot of people in the industry already know is there's 8,760 hours per year. And that's for a 365-day year. But once every 4 years, we get an extra day. So a fourth of 24 is 6. So if you wanted to be more average, you would say 8,766 hours per year. But maybe we'll just leave it at 8,760 because NREL has an 8760 based method for representing variable generation capacity values and capacity expansion models. So there's a lot of talk about 8760 when you're talking about modeling system performance and weather throughout the year and all these different databases. You will see this number, 8,760. Go ahead, Google it. So remember, just your load calculations. You have to get your units right and don't forget things. Those are the types of questions that you might see on a test, or it's easy to just make a little bit of a mistake and forget about the 24 hours and you're off by 24-fold of what your answer should be. So here's my buddy. We're talking about powers again, all these different types of powers. And don't forget that a horsepower is 746 watts. And the reason that we have to deal with this is because pumps are oftentimes based on horsepower. So here is a deep well submersible pump that's 2 horsepower. So it goes down underneath the water and pushes it up. If you try to suck the water up a deep well, you just create a vacuum and you're just sucking outer space. There's nothing much going on there. So you need to get under that water if you want to bring it up any decent distance and push that water up. And so 746 or watts or 0.746 kilowatts is a horsepower. And James Watt figured that out with a horse. And I'm going to go figure that out with a horse right now. Because yes, that's right, I have horses, or actually my daughter does.
So I hope you enjoyed that lesson from the 40-hour NABCEP Advanced Energy Storage Certification Training. If you want to sign up for that course, you can go to solarsean.com and you can find it that way. Or you can go to heatspring.com/Sean and that takes you to all of my HeatSpring courses. And I specialize in getting people NABCEP certified. And getting NABCEP certified is really important, especially as the markets are changing and different states are zooming and other states are not zooming as much. And if you want to make sure that your job is super secure, you will have the NABCEP certifications. Woo!